In this video, I will go through lab assignment 4, stopwatch design, and as all of you know, we have split this into 2 weeks, week 1 and week 2. So in this video series, we will just go through week 1 and kind of give you a refresher on what you will be needing to know on week 1. So first thing I'm going to show is what a counter is, and then we will learn how to design a counter, and then how do you simulate a sequential circuit, and how do you write your test benches to generate a clock, and then we will study edge trigger flip-flops and also how to model them using Verilog. So basically these are on a very high level things that we studied, we covered before spring break, and these are things that we will also cover in our video series today. The second thing that I would like to go through is push buttons and how push buttons are implemented, how to work with them, and also 7-segment displays. Most of you here are familiar with 7-segment displays, so I will just take like a minute or two to go through what 7-segment displays do and what they are. So week 1, so the first thing that you, when you want to implement your project is work with the 7-segment display. So if you go to your canvas under lab 1, assignment 1, there's a file called bcd to 7segment.v, which is basically a Verilog code for a BCD to 7-segment display. So what you want to do is just put it on the board and get familiar with it and test it. Right? Testing, I'm guessing most of you are familiar or comfortable and you know how to write test benches for BCD to 7-segment. The next thing you want to do is build a D flip-flop, more specifically an edge-triggered D flip-flop. So think about design and implementation. I will explain this as well, and then follow this by testing it in models. Lastly, you want to build a counter. So a counter is basically what it looks something like this. In this case, we are building a 4-bit counter. So you have a 4-bit D flip-flop, you have your reset, your clock, and then this is the architecture. This is a 1-bit adder, or actually it's a 4-bit adder, and it adds a 1 to your 4-bit input. And so this is basically a counter, and whatever your Q output is goes to your BCD to 7-segment display, through which you can see your output. Okay. Again, we will explain this also in today's video. So what you should be doing is your counter basically starts at 0 and goes to 9 and then loops. So 0 to 9 goes to 0, 0 to 9 and goes to 0. Keep in mind, you don't have to use any specific adder architecture. You can just tell the tool to decide what adder it wants to use. And regarding checkoffs, what we wanted to do is take a video of the working of your design and post it on Canvas, and then we will check you off like that, digitally or virtually.